Hello again. This is Joseph. Continuing with now understanding how fuses work, printed circuit boards work. We were discussing before about fuses and fuse panels. Well, like I said before, the weather is uncooperative today. It's been raining here in the Northeast quite a while. So therefore, I tried to find something that will visually explain what I'm saying until we're able to go outside under the hood. Now, you're all familiar with the fuses. This is what your typical fuse box looks under the hood. And this part is, over here, is the harness. All these fuses over here have connections in the back of it, underneath it. All those wires go through a harness. Now, as I specified one time before, they are color-coded. Just like the resistors, the through-hole resistors are color-coded. These are color-coded. These are through-hole. And sometimes you have resistors that are, if you can see of these are color-coded. Same thing applies over here. So in other words, yellow is for 20 amps, light green is 30 amps, amber is 40, red is 50, and blue is 60. Now, if you have a fuse, a maxi fuse, which I illustrated before, look at this color. Rated at 50 amps. If we go across over here, red. So obviously it matches. So, like I said, if you look at the cover, and sometimes it's not noted, if I'm looking for a fuel pump relay, and I look at the cover that is on top of this, I take it apart and I look at the cover, and I say, where is the fuel pump fuse? It's not listed. Or it's not specified. All I see is a bunch of fuses. Well, I look at the diagram. The diagram tells me I should be looking for, let's say, for example, a 25 amp fuse or a 10 amp fuse. I know the color of the fuse. So, worst case possible is, like I said before, this has been erased. I don't see 50 amp. I know red is 50 amps. Right? 50 amps is erased. I can't read the lettering on it. But I know red from my chart is 50. So let's say there's 3 or 4 of these. What am I going to do? Worst case possible, I'm going to check all the red fuses. Because those are denoted or specified to be 50 amps. I'm not going to look at the yellow ones, which is 20 amps, because I'm not looking for a yellow one of 20 amps. I'm looking for a 50 amp one, even though it's erased and even though it's not listed on the cover. That's the worst case possible. Worst case possible. However, usually the writing is still intact, but I'm just teaching you this so you'll know in the future. Yellow, yellow, yellow. See all these yellows over here? Yellow will be 20 amps, as you can see. So it depends on the type of fuse. Maxi fuse, big ones go by this. There's mini fuses. There's, as you can see, there's a fusible link, which we spoke about before. Therefore, keep this in mind. Now, the other thing is when somebody sent me an email specifying that he couldn't read. His meter was giving him crazy readings. I wanted to specify one thing, or point out one important thing. The type of probe that you have is important. These are, if you look at this, look at the difference in tips. This will fit to a big one like this one, like we just specified. See this? See the terminal? It can make contact with it, the big one, and the small one. However, when you get down to the mini fuses, the small ones, you cannot make sure that this makes contact. This is too big. You have to go in with a smaller one to make sure you're making contact. In other words, like I said, if these are very small terminals, you need something small like this and pointy. That's why I use this for the small ones. And making sure that I have contact. As you see over here, these are the long terminals. So no problem, I could use a long one. However, You do have small ones that look like a dot almost. And in order to make sure you're making contact with it, you have to use a small one to fit into there. And I'm going to show you an example. Like I said, weather gets better. A picture's worth 1,000 words. You'll understand exactly what I'm talking about. However, if you're not making contact, let's say I'm on this over here, and I'm not making contact, you're not going to get a reading. If I have 12 volts over here, and I have 12 volts over here, the voltage drop across it is 0. That tells me this is good. Like I specified before. If using a test light tells me nothing. So if I have 12 volts over here and I have 11.7, 11.6 volts, we know the fuse is good. But it also tells me current is flowing through this, through some complete path to ground. Might be the headlamps, might be a fuel pump, but the fact that I have current flowing in here tells me somehow something is connected to ground. So keep this in mind. When you measure fuses, have the correct probe point to use. Okay? Otherwise you will get false readings all over the place. And always 0 ohm your meter. Make sure I put it on 0 ohm, on ohms. Make sure it zeroes out, because if one of these leads are broken, you will get false readings. That's the first step in anything. Now, as I specified before, we would talk about different things. Now, if you look at the fuse panel about relays, each one over here denotes a terminal. So let's say some of them have 5 points terminals, some of them have 4 points. It doesn't matter. But each one, let's say this is the fuse distribution box. And like I said, until we go out there, this is a pretty good visual illustration of what we're talking about. So at least you have an idea. So therefore, these are relays. The purpose of them is specified over here what they're for. Some of them are spares. Some of them are for AC clutch. You know, the compressor needs a relay, fuel heater, all these things over here. But that's not written over there, obviously, on the fuse panel. That's just in this book that I used. And somebody asked me the book. The book is called Automotive Technology, which I got when I went to Lincoln Tech to learn automotive. And obviously now they don't use books. They use, obviously, they go online. So the hard copy obviously is not there anymore. But still, obviously, I always use it as a reference. This is where I learned everything from years and years ago. And still the same thing applies in today's vehicles. There's still relays. There's still color-coded fuses. The fuses are still red and yellow. Doesn't matter, it was from 20 years ago. Still the same concept, right? So, let's say the terminals are here. These are the number terminals over here. Of course, again, it's not going to show you in the terminals the number. What you will do is you'll take out the relay like we will do, and then on the side of it it'll tell you the terminals, it'll tell you the coil, and then it'll show you the switches on the contacts on the other side. Referring to 3087 might be the contacts, and the other one, as is usually, will be the coil itself. And like I said, a picture's worth 1,000 words, and you'll see it and you'll understand it much better. Now, this is a fuse puller. Usually you have a little fuse puller inside the fuse box to help you take out the fuses. Now, what I wanted to stress the point was, I said before in the previous video of measuring in-circuit testing, how important it is. A relay has to be tested in circuit. You cannot pull out this relay and say, I'm measuring just the terminals itself in the fuse box, and I have 12 volts here, I have 0, I have 12. That shows nothing to me. That is pointless and absolutely illustrates nothing to me. There is a difference of a load in a circuit than without the load, taking out the load. Now, as I said before, I told you I want to measure in circuit in the relay. How do I do that? The relay is inside the terminals. How do I do that? Well, I want to extend the terminals. Now, to me, there was many options. To extend the terminal, I can use actually a piece of solder. However, that piece of solder breaks very easily. Once I put the relay on top of the terminals, it breaks the solder, and then you might have solder going across terminals, shorting out terminals. Not a good idea. Other option, I could take a piece of wire, like this piece of wire, and strip it, and put that in there. Let's say I want to measure terminal 30, right? I'm supposed to have 12 volts over here. But since the relay is in there, and since I want to measure in circuit testing, because that's the only accurate reading that I have, I cannot get to that point because the relay box is on top of it. I want to extend it. I could use this wire, strip it, put this stripped wire in here, and then put the relay. But you know what's wrong with that? There are strands in this wire. Strands break off. When strands break off, guess what? It'll end up shorting other terminals that are not supposed to be shorted. Not a good idea either. That's the worst case for me, to take a wire, strip it, put it in here, and have strands all over. Then you're causing more problems. The thing that I came up with is, and I'll show you, see, these diodes, or this is a kit, or these resistors that you've seen through holes. I take this is skinny enough, not thick enough, it won't damage anything. I take this end of this resistor or diode, whatever it is, I stick it in the terminal. Then when I'm ready, I put the relay on top of this resistor, with the relay being inserted in and the end being exposed out. In other words, I extended the terminal. This in turn will give me to measure the terminal even though the relay is already inserted in it, and I can measure the voltages. So therefore, you'll see it, hopefully, like I said, hands-on will do it, then you'll understand it. If I have this resistor, I take this resistor, I attach it to, let's say, to this one. I put the relay back on top, and guess what happens? The other end of it, all this is being exposed to me, and then I can go and measure the voltage in circuit. That's the most important thing. Excuse me. That's the most important thing, is to measure it in circuit. I want to know how the components are activated when it's in circuit, like the video that I just made to you a couple of days ago, I believe. If I measure 11, remember, the relay without is going to measure 12 volts. So what? All that tells me is the fuse is good. So what? When I have the relay inside, remember that 12 volt might drop. So it might be 11.7, 11.6 at this point, at this terminal of the relay. That's good. We want that. Why? It shows me that current is being drawn through the relay and through the circuit that it is connected to. It could be a headlamp, could be anything. I know the fact that it dropped from 12 volts to 11.37 volts or 11.7, 11.5, whatever. It shows me current is being drawn on this side of the relay. Most important. That's why you have to have a relay inserted inside and do these tests, these measurements in circuit. There is no sense in the world to take a relay out, measure and say the load side is 12 volts, this is 12 volts. Makes no sense in the world whatsoever. No sense whatsoever. So, like I said, we're going to take this resistor, whatever it is, stick it in here, put the relay on top of it, exposing the wire. So I extended the extension from this terminal to the outside. Now I just put my probe to this here or here, and I'll measure the voltages. This is thin enough. It won't break. As you'll see, it won't break like a solder or a stripped wire. Stripped wire has strands. It'll break. This will not break. And it can be bended just in case I'm in a crowded area over here. Excuse me. So anyway, You'll see it, you'll understand it much better. But before I do something, I like to go and explain it before. About printed circuit boards that I was talking about before, this is the through hole. This is through hole, this is surface mount, obviously. PCMs or PCM boards, like I used to repair, they are double-sided. And before I spoke about it, but I didn't give an illustration. Double-sided means there are a component on one side, component on the other side. In between these, the top one and the bottom layer are other layers in between, like a sandwich. Those are used for sometimes B+, sometimes for grounds in between. So now at least you understand what I'm referring to. So therefore, if I'm soldering a point, and let's say there is a crack. Let's take a good example. Let's say there is a crack over here. I find a crack over here, that this is broken, right? First of all, I want to see how far the crack is. Did it reach this one also? This is another connection. Did it reach this one also? That means both of these lands are broken. However, even if I repair this and I make, let's say this goes from here to here. This is broken over here. So what do? I put a jumper from here to here. Problem solved, right? Nope. You don't know what's underneath on the other side. You don't know how deep the crack is. It might affect the other side or the other layers in between. If I have a relay board with one layer on top, the relays are just one layer, and I go and there's a crack on the board and I go and I fix it, fine, I can fix that problem because it's only one layer. These are multi-layer boards. I've seen boards that have 10 layers in between. Can you imagine? Layers 10 in between these. Grounds, B+, everything. They want to make the boards small, obviously, so we can make the computer smaller. And that's the idea of it. That's that. Now, the other thing that I wanted to show you, like I said, when we talk about PCM boards, this is the PCM board. I wanted to give you an illustration of what we're dealing with, and that's the board you just saw. Anyway, now this is the computer. How do I know it's a computer? When you go under the hood and you see so many wires, 100, 200 wires coming out of something, you know that's the main computer. But nowadays they have the BCM boards also with a lot of wires, cool. But when you see a heat shield across it or something to dissipate the heat, you know it's a computer board. Now the other thing is that I wanted to specify about batteries. When we spoke about batteries, now believe it or not, at 12, what is the state of your charge? Like I said, 20 years ago, still hasn't changed. There's still a state of charge. 12 or 6.6 on a 70 or 80 degree day, maybe you're 100%. Anywhere from 12.4 to 12.6, guess what? You're already at 75% to 100%. As the weather gets colder, your open circuit voltage, what does open circuit voltage means? When I take my meter and I measure across the terminals of the battery, not connecting it to a load or anything, just to the meter. It is open, meaning it's not connected to anything. When I'm at 12.2 to 12.4, I'm already at 50% charge to 75% charge. Believe it or not, that's why I stress meters that are high input impedance to give you accurate measurements. You're going from 75% to around 50% by just losing 0.2 volts. You're going to buy a Harbor Freight meter. You think you're going to detect that? That's why you use these these meters that are high input impedance. And you can always put on millivolts. When it is very close, 0.2 volts, I could put it on millivolt scale and measure the difference. But what I'm saying is that on a 40 degree day, a 30 degree day, you're going to go less and less and less. As you can see, the state of charge goes down. Once you're at 11.7 to 12, you're already at 25% or even less. Can you imagine? This is what I'm trying to tell people. If you measure, it's 30 degrees outside, and I go to the battery and I measure 12 even, I'm already at 25 to 50%, right? It makes a difference to have the right meter. Now, the other thing is, let's go over here. What I wanted to point out, and this is my last point. We just talked about battery temperature. That's why I have a battery load tester that has a temperature compensator. It compensates for the temperature. There are many load testers for batteries. However, let's look at the chart. Again, 20 years ago, nothing has changed. It's still 70 degrees outside, and it's still 10 degrees outside, and it's still 20 degrees outside. If you're in Green Bay, Wisconsin, it's still 10 degrees, 20 degrees in January. Nothing has changed. The minimum test voltage, meaning, when I do my load test and I put my tester on it, the lowest that I can come up with is 9.6 volts. That's the minimum test voltage that the battery will be good at 70 degrees. Again, I went to Wisconsin, Green Bay, Wisconsin, to watch the Packers play, right? To watch Aaron Rodgers play. 10 degrees outside. Look at the test voltage. Before, 9.6 volts was acceptable as the minimum test voltage. Because the state of the battery had degraded because of the weather, obviously, the cold, we're now allowed 8.7 volts to be the minimum for us to pass the test. Now, some meters, some testing test equipment to put a load test do not have a temperature compensation. However, the one that I will show you, it has a temperature compensation where you can adjust for 40 degrees, 30 degrees, and it takes into perspective, let's say, into analyzation, how much the minimum should be. If I take a regular test meter, it might pass me on 9.6, my 9.6. However, I'm at 10 degrees. 8.7 is good. If I'm at 0, Chicago, right? Chicago, Illinois, home of the Chicago Bears, 8.5 volts is acceptable. I have to put a temperature compensation in it. So therefore, I thought it was an important part to tell people, because when we go outside and when we do these things, I want people to understand what we're doing before we get out there and we do it. Just like, just like in the illustration over here, when you're going to go and put the tester on the battery, this is a type of tester that they used, actually, years ago. Same thing applies. You're still putting it across the battery, and you have an inductor pickup over here. So therefore, when you see these things and I do these things, I hope that you will be more familiar with these things. That's why I take the opportunity to inform you before we do things. Now, I want to thank the comments and all that have been going around. Like I said, anybody has advice, for how to rank the videos much higher, I would appreciate it in the comments. Everything is appreciated. Thank you.